In this example, they want us to graph a function with the following information. They want the first derivative to be greater than 0 on the interval negative infinity to 1, and then they want the first derivative to be negative on the interval 1 to infinity. So if the derivative is changing from positive to negative, then that makes a critical number at 0. Or not at 0, at 1. So we can go ahead and put a dash at 1 on our x-axis. Something's going to happen there. And it's saying that it's positive on that interval, so that would mean increasing. If the first derivative is positive, then it's increasing there. And it's negative on this interval, so that would be decreasing. So if the first derivative is negative, then the function is decreasing. So we can generally just kind of sketch something here. It's going to be increasing from negative infinity to 0, and then decreasing, increasing, and then decreasing. So what does that mean? That means there's a maximum at 1. Maximum at x equals 1. So critical number, and that critical number is a maximum. So we'll keep that in mind, but we don't know for sure what the rest of the graph looks like. Let's look at the second derivative. The second derivative talks to us about concavity. So here the second derivative is greater than 0, so it's positive. So that means it's going to be concave up. Concave up. And then it changes concavity. It becomes negative on this interval, and that's going to be concave down. And if we're changing concavity, then that means there's an inflection point. Anywhere where it changes concavity would be called an inflection point. And actually, there are two of them. So there's an inflection point at -2, and there's going to be an inflection point at 2. So inflection points of -2 and 2. 2x equals -2. So let's plot those. 2 and -2 is where it's going to change concavity. So what does that mean? So if I use these rough sketches from before, so to the left of -2 is concave up. So we can kind of make it concave up. And from 2 to infinity is also concave up, so we can kind of do that. So curve. And then from -2 to 2 is concave down, so we can kind of do that. So we're starting to get a better idea. And then we need to look at these limits that they give us. It says the limit as x approaches -infinity is -2. So remember, whenever a limit approaches infinity, it's giving you a horizontal asymptote. So there's a horizontal asymptote then at y equals -2, and over here at y equals 0. So that means on the left side, we are going to level off at -2. So the left side is going to follow that asymptote. And then the right side is at 0. So the right side is going to level off right here. So now we just want to combine all that stuff together. So from -2 and over, it is concave up, and it is increasing the whole time. So we can do that like this. And then from -2 to 2, it's concave down, and it increases. It's still increasing until it hits 1. So concave down, but increasing. And then we have decreasing the rest of the time, but it's still concave down until it gets to 2. So it gets to 2. And then we change concavity, but we're still decreasing, and we need to level off towards this asymptote of 0. So here were the points where things changed. -2, it changed concavity from up to down. 1, it changed from increasing to decreasing. And at 2, it changed concavity from down to up. And so that is a rough sketch of what they gave us.